In previous lectures, we have explored how data travels across networks using TCP and UDP, which are the two transport layer protocols responsible for delivering information between devices. But here's the question, what exactly are they delivering? What kind of data are we sending when we browse a website, sending an email, or downloading a file? That's where today's topic comes in.
Hi, I am Imran Afzal. I make learning technology easy, even for beginners in IT. So I have over 25 years of experience in Linux administration, Windows, virtualization, and many more. I have taught millions of students worldwide.
In this lecture, we are going deep into the application layer protocols. You have already known the application layer is the topmost layer in both the OSI and TCP/IP models. This is the layer closest to the user, and it is where the services we rely on every day are defined. So whether you are watching a YouTube video, checking your email, or logging into a website, you're interacting with an application layer protocol. Before we start learning about application layer protocols like HTTP and DNS, let's clear up something important. We have already studied TCP and UDP, and yes, they are protocols too, but they belong to the transport layer, which means their job is just to deliver data between devices. They don't care what the data is. Imagine them like delivery drivers. The application layer, on the other hand, is where the meaning of the data is defined. It tells us whether the data is a web page, an email, or a file, and it interacts directly with users and software. For example, when you visit a website, your browser uses HTTP to request the page, but that request is carried by TCP underneath. Similarly, a DNS query is formatted by DNS rules but delivered by UDP. These layers work together where application protocols define the service and transport protocols handle the delivery. Now, there is also the network layer. It includes protocols like IP, ICMP, and ARP, which we will understand in detail right after this lecture. Its job is to figure out where the data should go and how to get it there. It is like the GPS system guiding the delivery truck. It doesn't care what is inside, they just know how to reach the destination. Before we dive into individual protocols, let's clear the idea of a protocol. A protocol is simply a set of rules or an agreed upon way for devices to communicate. Think of it like a language. So if two people speak the same language and follow basic conversation rules, they will understand each other. But if one speaks French and the other speaks Mandarin, the conversation won't go very far. In networking, protocols ensure that devices understand each other, follow the same rules, and exchange data in a predictable way. Every layer of the OSI model has its own protocols, each with a specific job. Some protocols are stateful, which means they keep track of the session and remember past interactions, like TCP. Others are stateless, which means each request is treated independently, like HTTP. Most protocols follow a client server model where one device requests a service and the other provides it. Some protocols are designed for reliable delivery, while others prioritize speed and simplicity. The application layer protocols define how services behave, how a browser fetches a web page, how an email is sent, or how a device gets its IP address. Understanding these rules helps us see how different parts of a network work together to make communication possible. So let's start exploring them. Let's begin with the most familiar protocol of all, HTTP, or Hypertext Transfer Protocol. This is the protocol behind the World Wide Web. When you type a URL into your browser, it sends an HTTP request to the server hosting that website. The server responds with the requested HTML, CSS, JavaScript files, which your browser then displays. HTTP is a stateless protocol, which means that each request is independent and does not remember previous interactions. It uses TCP underneath to ensure that the web page arrives intact and in the correct order. You can think of HTTP like walking into a library and asking for a specific book. The librarian finds it and hands it to you. That's HTTP in action, simple, direct, and reliable. Now let's add a layer of security. HTTPS or secure HTTP is the encrypted version of HTTP. It uses SSL/TLS encryption to protect the data exchange between your browser and the server. This is especially important when dealing with sensitive information like passwords, credit card numbers, or personal messages. Before any data is exchanged, your browser and the server perform a secure handshake to establish an encrypted connection. Once that's done, HTTP takes over, but now everything is wrapped in a protective layer. It is like having a private conversation in a soundproof room instead of shouting across a crowded cafe. HTTPS also uses TCP, which ensure both security and reliability. Next, we have DNS, the domain name system. DNS is often called the Internet's phone book. Its job is to translate human friendly domain names like google.com into IP addresses, something like 142.250.190.78, which computers use to locate each other. When you enter a website address, your device sends a DNS query to a DNS server. The server responds with the correct IP address, allowing your browser to connect to the right destination. DNS typically uses UDP for speed, but can fall back to TCP for larger queries. Imagine trying to call someone without knowing their number. You would look it up in a phone book. That's exactly what DNS does, and it happens in milliseconds. Let's talk about DHCP, or Dynamic Host Configuration Protocol. This protocol is responsible for automatically assigning IP addresses and other network settings to devices when they join a network. When you connect to Wi-Fi, your device sends a DHCP request. The DHCP server responds with an IP address, subnet mask, default gateway, and DNS information. Without DHCP, you'd have to manually configure these settings every time you joined a network. DHCP uses UDP since the process is quick and doesn't require guaranteed delivery. Think of DHCP like checking into a hotel. You walk up to the front desk and they assign you a room number, give you a key, and tell you where the amenities are. It's fast, automatic, and efficient. Term related to IP addressing will be covered in next lectures. Now let's move to FTP, or File Transfer Protocol. FTP is used to upload and download files between computers over a network. It is commonly used in web development, server management, and data sharing. When you connect to an FTP server using an FTP client, you can browse directories, upload files, or download them. FTP uses TCP to ensure that files are transferred reliably and without corruption. Imagine accessing a shared folder on someone else's computer and copying files to and from it. That's FTP in action. It's a bit old school, but still widely used in many industries. Next is a SMTP, or Simple Mail Transfer Protocol. SMTP is the protocol used to send emails from one server to another. When you hit send on an email, your email client uses SMTP to push the message to your mail server, which then forwards it to the recipient server. SMTP works closely with other protocols like OP3, and IMAP, which handle receiving and storing emails. SMTP uses TCP to ensure that messages are delivered accurately and in full. You can think of SMTP like dropping a letter at the post office. It handles the delivery, making sure your message reaches the right mailbox. Finally, we have SNMP, or Simple Network Management Protocol. SNMP is used by network administrators to monitor and manage devices like routers, switches, and servers. Each device runs an SNMP agent that collects data like CPU usage bandwidth and error rates. A central SNMP manager queries these agents to keep track of network health and performance. SNMP uses UDP for lightweight communication, making it efficient for large networks. It is like a doctor checking vital signs across multiple patients in a hospital. SNMP helps ensure that everything is running smoothly and alerts administrators when something goes wrong. In the next lecture, we will learn about the network layer protocols. I will see you in the next lecture.
I hope you learned something useful in this video, and I will see you in the next one. But please wait. Don't forget to subscribe.